because there's been absences and it's an interesting conversation, I'm going to record it. So when we find slope, this number, this 2/3, doesn't have to be changed to a decimal. In fact, a lot of times it's more helpful it's not a decimal, because you can actually see in the picture the rise is up 2 and the run is over 3, just like that little cartoon stairway thing. So if it's proper fraction, leave it. Now, there might be times where you want to change slope to, and remember, rise over run just stands for slope, which is also already changed. You might want to change it to a decimal if it's a problem involving money, like some of the fundraising problems. But when it's just a graphing picture, sometimes we just like the fraction because it's so easy to work with. Does that make sense? Question?
Well, like, I don't really know how to like ask this, but like if you start where the arrow points, like where
You
it crosses
can't.
the Y-intercept.
Good question.
You can't start there.
You can't start here because you don't know the exact point.
Yeah, that's what I thought.
So it's not exact there. So you don't want to start there.
Okay, yeah, I was looking at it because I thought it went like straight through one.
Right.
It's like, wait, one half is it?
So just to kind of clarify, if I had cleaned this up when you re-look at it and you're starting the problem, the first thing you want to do is you just want to look for an exact point. And in this problem, they're pretty much just showing it to you, right? They put a big dot there and they put a big dot there, and so you know you go up 2, that's your rise, and then you run 3, that's your run. And another way to think of it is the change in y, which is what that stands for, divided by the change in x.
Yeah.
And that's handy for the tables, because that way you just see what's happening to y. It's going up 2 units, and x is going up 3 units. So the change in y was 2, and the change in x is 3. And so basically, if they don't have any common factors, then you're just going to say your slope is 2/3. And you know how we used to talk about, and we still do sometimes, fraction bars mean divide? I mean, if you think kind of what we would do in a ratio table situation, some of you might want to divide by 3. Well, you get a 1 here, but remember, fraction bars mean divide, so 2 divided by 3 is just 2/3. You still just get a fraction. Leave it as a fraction. Okay? Jada.
So why did you flip it?
I didn't, and that's exactly like,
No.
so the order of x and y?
No, like you have 2 on the bottom and then 3 on the
Yeah, I did it. This is what you see in the book here, this table. Okay? They have the x and the y like that, but you are used to also seeing it left to right, where you have 2, 5, and you have it written this way. And so you see 3 different ways. So you see me a lot of times do this. But I still do the change in y over the change in x. And that's why, like, the term rise and run is great. This is great with a graph. But when you don't have a graph, if you say change in y over change in x, I think you're going to make less mistakes, because you always know what goes on top if you keep just telling yourself change in y over change in x. Because the book writes it both horizontally, and sometimes they write it vertically. So think of y being on top. Okay? Jack and then Awen.
So I know we're not there yet, but for problem 3, I realized that it is easier on tables to use the change in y or change in x.
Yes. So we can be on that problem though. Like on this one here.
No, the one after it.
Oh, the one after it. Yeah, we'll do that in a minute. Okay. I'm going to pause. So the question is, can your slope change? Well, for a line, there's just one slope. What you might see as problems get more complicated is you might see like 2 different lines connected, but we aren't there yet. You might see a line like this, and then it might get steeper. Then you'd have 2 different slopes. Because for each line section, there's just one slope. So once the steepness changes, you're going to get a new slope. But if it's smooth line, just one line, not two pieced together, you're just gonna have one slope. And so, on this problem here, like, the next question was, somebody was asking about the negative. So when we read left to right, so if you think about, like, looking at this problem left to right, you know, you would be kind of sliding down if this were a slide.
Yeah.
Does that make sense? And so if you're sliding down, it's a negative slope, and that's really the only difference. So you can either just decide right away that you're going to have a negative in your head, but what's happening in the picture is you're dropping. So when it, instead of rise, it's really drop. But we just still say rise over run, just because you can train yourself, and I'll show you why. But I'm dropping 2 units here, and I'm going to the right 3 units. So this is a -2 third slope, which means it's the same exact steepness as the graph above, but it's going the other direction. And if you really are the kind of person that just bugs you, because we say rise over 1, but I went down, start at the lower point. You rise 2, and you run 3 to the left, so your negative shows up one way or the other. So you could have written, like, up to left 3, but the negative's still there. So in the end, what you'll most often see is the slope is negative, and then you just put the fraction. But all 3 of they're all correct. Does that help? So in a table, if we do kind of what Jack was saying, think change in y over change in x, remember here y is dropping 2 units. So we use a negative. And x is increasing 3 units, so it's still positive. So it's a drop of 2 for every 3 to the right. So we still get the same thing. No matter how I look at the problem, I'm still getting slope is -2 thirds, no matter how I look at it. Okay? How are we doing on that? So Jack said, when I look at this problem, which way is easier for you to think of this, rise over 1 or change in y over change in x?
Changing y over change in x, because the rise over run, I see it more in the graph.
Yeah, I agree. So I think for me, change in y over change in x is easier, but just because that's what I think, you could think of it as rise over run. You don't even have to use, because the question says describe how you can find the slope of the line, since it's telling you it's a line, going back to Ayla's question, you could get the slope here, the change in y is 3 units, and it's going up 1 unit, but it should never change. So if somebody decided to go the change in y from here to here, it's going up 6 units, but then I have to look at the change in x here going up 2 units. So I could have done the slope, the change in y over change in x is 6 over 2.
But like you could think of it as like you can run on the x-axis because it's flat. You can't run up the y-axis because you can't run up.
Sure.
Okay.
I think you have to decide, you know, what's best for you. But I think what I'm trying to show you is that, like, Awen had a pretty important question. Since the slope is always the same within a line, you could pick any 2 points and find the change in y and change in x. It should still reduce down to the same slope. So I got 3 over 1 here, and I got 3 over 1 here. So we would just say the slope is 3. But if we were drawing a graph, we would probably want to think about that 1, because it helps us draw the picture. Like, can you see that the graph starts up at 3 units?
Yeah.
So once you get that little 0, 3 here, now I can use my slope of 3 over 1, which says my next point's up 3 to the right 1. And then I could draw my line in. I could just take a nice straight line and put it in to the picture just like that. And I should be able to extend it forever and get any point that I want. And if I keep going up 3 over 1, and of course I don't have graph paper, so it might not be perfect, but I should be able to still get basically, oops, a little off. I should be able to just go up 3 over 1 and see this little triangle is up 3 over 1. So I should be able to do it again, 1, 2, about 3 over 1. My line really, if I was on graph paper, would be perfectly in line with that. And the disadvantage of not having graph paper is you can see I'm a little off, but I can correct it. Does that make sense? Okay. So it's kind of like slope summary. So let's look at this page, and I'll pause this, and you can read these and try some of these. Okay. So, Kemper, what'd you get for the slope on graph 1?
I was actually having a pretty hard time with it.
Did you get graph 2?
No.
Okay, so is it because you are having trouble finding exact points? Or you're just not sure where to start?
I'm just not sure where to start.
So when you look at this one, it's easier because they put the dots there. But here you have to like look like for an exact point, like there's an exact point, and then here's another exact point. Does that make sense?
Yeah.
And so if I'm going to do graph 1, I'm going to think of rise over run. So graph 1 is dropping 6 units, and it's going to the right 2 units. So you can think of it as a negative slope because it's going downhill, and if the vertical changes 6 and the horizontal changes 2, so it's just a slope of -3. So slope is rise over run, it's just -3. So the only difference between the left graph, Daniel, and the right graph was what? One's decreasing and one's increasing. But like when you look at the amount of decrease and the amount of increase, it's the same. So here's a key point, and here's a key point. So I'm rising still 6 units, and I'm still going 2 units, but this time I'm going up and to the right, so it's uphill, so it's positive. So it's the same steepness, but the opposite direction. That's the difference. Thumbs up or thumbs down, guys? Question, Jada?
So, sorry, again, M is the rate of change, right?
M is the rate of change. So rate of change.
Sorry, I always mix up.
Means slope, which is M, which is, that's a funny M, change in Y over change in X. They all mean the same thing. I can't move that. Okay, so all of this means the same thing. Just a bunch of different ways to say the same thing. Okay? Want to try the table, Jada? Pick a table. Table 2. Okay, so are you going to use slope, rise over run, change in Y, change in X? What's easy for you? Change in Y over change in X. Okay, so that's using these little change in Y over change in X. And
That's 0.5.
up or down.
Yeah.
So it's decreasing a half per
For one.
1. So it's just 0.5 over 1, which is just 0.5. So the slope is 0.5 or a half. Okay? Does that help? Okay. It is negative, thank you. So the slope is negative 0.5. I almost forgot that, even though James said it. Okay, so do this slope here. Ethan, what's happening here? Are we going up or down on the y's? Think about it, we're going from negative 10 all the way to positive 2. We're going up. How much? 3. For every up or down there? For every up of 2. So the change in y over the change in x here is what? 3 over 2. So we haven't written any equations yet, but before we write equations, we have to get the slope down. Does that make sense? Yeah? Okay. So if I brought in just a blank page, so there's more room, and I went back to graph 1, and I wanted to write an equation, I would just remind myself that I'm doing y equals mx plus b for graph 1, because it's a line. And I know a few things. I know the slope. So Gabby asked, what was the slope for graph 1? Right. So because I already know that, I'm going to write y equals negative 3x. But I have to find b, and b's the y-intercept. So Julian, looking at graph 1, where does the line cross the y-axis?
In the 6.
It's 6, right? Right here it's 6. So if you look at that, it's 6. So you were asking about the equation. That's the whole equation of that line. That's all it is. So what's the difference between the equation for graph 1 and the equation for graph 2, Daniel? Yeah. What's the equation for graph 2?
Oh.
Still going to be y equals mx plus b to start with.
Yes. But it's 1 equals 3x plus 6.
Right, because it was positive slope of 3.
Yes.
And when you look at the picture, it also starts at 6. So that's graph 2. So, Naomi, can you do the equation for table 1? That might be a little harder, but you still start with y equals mx plus b.
So y equals
Go to table 1. What was the slope?
y equals 1.
No.
Wait, oh no, sorry.
So table 1, let's zoom in. It's change in y over change in x.
I thought one for mine would change.
Ah.
I did that wrong.
So here it is. The slope
Oh,
is 3 halves because, and we can cross check it, right? This is going up 3 units for every 2.
Oh, okay.
So maybe you had a careless mistake there.
Yeah, I think I did.
So y equals, what's the slope then?
So the slope is,
So that was, you were absent when we practiced this.
Yeah.
It would just be 3 halves x.
okay.
The slope is 3 halves. You don't have to find decimal. You could put 1.5, but you don't need to.
I did.
You could. They're both correct. But then, Brandon, where is the y-intercept when you look at the table? Looking at that table, how can you tell?
-1.
How do you know?
X is at 0, that means it's the y-intercept.
That's right. Here's the y-intercept for table 1. So that tells us B is -1. Because when x is 0, look at the y-intercept up here. I don't know if you guys heard Julian. When I asked him, he said 0, 6. Even though I wrote down 6, because that's what the equation has us do, he did say 0, 6, which was really specific. So where x is 0, whatever is with 0 is the y-intercept. So this would be -1, or you could write plus the -1. You guys get that? So.
Wait, let's just see. I have to do everything plus the equation.
Okay, let's just try it. Try one more equation. The -1 came from right here, the y-intercept. So look, table 2, it's normal, like this is a lot of stuff, you guys. So table 2, I'm just gonna always write down my rule, y equals mx plus b. Then I look at table 2 and I ask myself, did I find the slope? What was it? -0.5. And so then I go to the table and I find when x is 0, can I find the y-intercept? And it doesn't really show it to me, so I have to think backwards. If I went down one more to 0, I'd have to go to 5. So it'd be -0.5x plus 5. And that's my equation. So that's a little bit more of a level 3-ish thing because you have to find the intercept.
So it's like the intercept is just like where does like the 3 halves come from?
The 3 halves was the slope. It comes from the change in y over the change in x. Here, the slope. And the intercept comes from where the graph hits the y-axis. So, look at the problems tonight, guys. They're on the website. I'll bring them up. Let me stop this.